Hi, good morning. Today we're going to review related rate problem. So the main idea is when we are working with related rate problems, we are finding derivative of equation with respect to a hidden variable t. The related variable are each function of time t. So let's take a look at a simple question and review what it means that related variable are each function of time t. Question number 1. Oil spill from a water tanker spread in a circle whose area increases at a constant rate of 6 square mile per hour. How fast is the radius of the spill increasing when the area is 9 pi square mile? So the shape of the oil spill is going to be a circle. So as the oil going to the circle, the circle's area is going to become bigger and bigger. So as the time passes, the area increases. So therefore, the area is a function of time. So A equal A of t. And then as the area increase, the radius also increase. So therefore, the radius is also a function of time. R is R of t. And then, of course, the diameter is increasing, so the diameter is also a function of time. So d equal dt, and the circumference also a function of time. So that is what it means the related variables are each function of time. Now, let's take a look at question number 1, and we're going to solve it together. So here it says that the circles whose area increase at a constant rate of 6 square mile per hour. So it means A prime of t, or dA dt, equal to 6. We are going to review two different notation today. A prime of t is dA dt. So how fast the radius of the spill increasing? So we had to find R prime t, or dr dt. And then the area is 9 pi. Area equal to 9 pi. That means A of t is also 9 pi. A is A of t at that moment. So now we had to find equation that relate this information. So which is going to be the area formula for a circle. So now A is A of t, and then R is R of t. So now we are going to find a derivative. You get A prime of t. Derivative of A of t is A prime of t. Numbers stay the same. And then you have 2 going to the front. And then this subtract 1 become 1. I'm not going to write it. And then you have R of t. So the derivative will be R prime of t. So this we just use the chain rule. So we already reviewed chain rule for quite a while. So therefore I believe this is going to be easy for you. So now we are going to do substitution. So this is 6, this is pi, and then 2. What is R of t? R equal R of t. Okay, just like A is A of t. So now we have the information to help us to find the radius. So cancel. So now we got the radius is 3. So now we're going to substitute. So you get this. Next step, we just solve for R prime of t. So we get 6 equal so R prime of t equal to 1 over pi. Because this is one dimensional, so we just put mile per hour. So it tells us the radius increasing at 1 over pi miles per hour. Positive, it means increasing. So we finished using one notation. So now we're going to do the second set of notation. So A equal to pi times R squared. A is a function of time and radius function of time. So we had dA dt. Numbers stay the same. So we put the 2 in the front, exponent 1, and then we're going to times dr dt. So some people will say, how come you don't use A prime and r prime. So after we review the implicit differentiation, some people got confused. So therefore, I want you to stick with the dAdt, dRdt, or a prime t, r prime t. So this way you will not get confused. Okay, so some people will find it this way. It will be a little bit easier to differentiate from the implicit differentiation. So now next step, we're going to do substitution. So we just solve for it. So we got the same answer. So there are two set of different notation. So you can stick with this way or this way. Okay. So on the AP exam, we don't know which one they want you to see, but it's good to know both. Now let's take a look at question number 2. Question number 2. So we had a spherical balloon. It's deflated with helium at the rate of 100 pi cubic feet per minute. So when you see this unit, cubic feet is 3-dimensional. That has something to do with the volume. So that means this is a sphere. And then the air coming out is getting smaller and smaller. So that means V prime of t equal to negative 100 pi. So how come it's negative? It's because we're deflated, so the volume is getting smaller. So that's why the size getting smaller. You use negative for the derivative or the rate. So dV dt equal to negative 100 pi. So different notation. Now, how fast is the balloon's radius decreasing? So you have to find the rdt or r prime of t. So at the instant of 5 feet, so that means r equal to rt equal to 5 feet. So now we are going to find equation that relate all the information together, which is going to be v equal to 4 over 3 pi r cubed. So v is v of t, and then the r is r of t. So now we find the derivative v of t, you get v prime of t. Numbers stay the same. Now you're going to use chain rule, 3, and then subtract the exponent, you get 2, 3 minus 1 equal 2, and rt stay the same side, and immediately multiply the derivative, which is r prime t. So this is just a chain rule. We had to review using chain rule for about 2 weeks. So I believe many of you will find it pretty easy. So now we're going to do substitution. So you got the information. So we have negative 100 pi. And r is 5. So now we're just going to simplify and solve for r prime t. So this cancel, you get 4 pi times 25. And then we get negative 100 pi equal to 100 pi times r prime t. So we divide, and then you get negative 1 equal to r prime t. 1-dimensional, so therefore it will be feet, and the time is minute. So that means the radius is decreasing at 1 foot per minute. The radius decreasing at 1 foot per minute. So the decrease comes from the negative. Now we're going to use another notation. So we get v equal to 4 over 3 pi r cubed. V is function of time, r is function of time. So now we're going to have dv dt equal to, the number stay the same, number and number. So over here you put the exponent to the front, and then you get r squared, and immediately you do dr dt. So one more time, I suggest you use this notation. If you don't like this one, don't use v prime and r prime, because some people already got confused when they're doing the implicit differentiation. So every time when you have the related rate, you have to use a time in your derivative. Now we do substitution. And the next step, we're just going to solve for dr dt. And then we divide by 100 pi. So dr dt equal to -1. So the negative tell us the radius is decreasing at a rate of 1 foot per minute. The negative sign tell you use the word decrease. Decrease at a rate of 1 foot per minute. That means -1 foot per minute. So we finished question number 2. So I want you to go to video number 2 to take a look at how I solved the other problem related to a triangle.